Welcome Algebra 1. So we are starting combining like terms today. We're not starting it, we're gonna start and finish it. This is actually our last section of our first chapter. So the first chapter is pretty quick and hopefully it was primarily a review, but we are gonna dive into combining like terms today. So let's get into that. Hopefully you are putting this into your spiral. Like I am. Okay, so combining like terms, let's first talk about what a term actually means. So a term is a number or a variable or a product. And we're thinking, what does product mean again? Product means multiply. So product, so two things being multiplied together of a number and a variable. Oh, can I squeeze it in here? I think I can. Okay, so let's kind of look. Oh, you can't even see that. Let's look at this. Let's just kind of write an expression out. So if I did 6 plus x plus 5x plus 2/3 plus 2xy plus 10x squared. Okay, so all of these are actually considered terms. So we have 6 is a term. X is a term. 5x is a term. 2/3, 2xy, 10x squared. All of those six things are considered terms. Notice that terms are often separated by either addition or subtractions. Symbols. I don't know. Terms. Okay, so then let's talk about what a coefficient is. So coefficient is the number being multiplied by the variable or variables. So the number being multiplied by the variable or variables. So if I gave you an example like 5x squared, the coefficient is the 5. So the coefficient is just the number without the variable attached. So that's the coefficient. Okay, that really ran into that, didn't it? So if I were to look up here, 5x, 5 is my coefficient. If I were to look at 2xy, 2 is my coefficient. If I were to look at 10x squared, 10 is my coefficient. If I were to look at 2/3, there is no variable there. 2/3 is the coefficient. So the coefficient is always just the number by itself without the variables attached to it. Okay, now let's talk about what a like term is, because that's essentially what we're doing, combining like terms. So like terms are terms that have two things. So one, they have the exact same variable. So if they have an x, the other one has an x. If it has a y, the other one has a y. So that's one exact same variable. And then the second criteria is that the variables that are raised to the same exact exponent. So x and x squared are not like terms. They don't have the same exact exponent. So variables that are raised to the same exact exponent. Okay, so now some kind of side notes to mention too. Constants. So constants are numbers without variables. Constants are like terms, which you guys kind of already know that. That's something that you've already seen. So constants are like terms. So an example, like 8 and 2, those are like terms. We can combine those. You can add those, right? 8 plus 2 is 10. We can combine them. We also, let's talk about coefficients. So coefficients do not have to be the same for them to be like terms. So coefficients do not have to be the same. Okay, so let's kind of go through and let's make a little bit of a chart where we're looking at like terms compared to unlike terms. I know maybe not unlike terms is the best word for it, but here we are. Okay, so let's make a chart. So we have like terms. And then we'll do another one with unlike terms. We'll make just a small chart for ourselves here and separate those. Okay, so let's start with like terms. So like terms, again, remember they have the same exact variable and the variables are raised to the same exact exponent. So if I gave you 5x squared and negative 10x squared, those would be considered like terms because they both have an x and that x is raised to the second power. The coefficients in front don't have to be the same, so that's okay. And let's keep going. Let's think about an example of unlike terms. So an unlike term would be something like this. 3x squared and 6y squared. So those are unlike terms. Those are not like terms. Those cannot be combined. So with that, the reason why those are different and we can't combine those are because of the variables aren't the same. So we have an x, we have a y. So even though the exponents are the same, the variables also have to be the same. So these are unlike because they have different variables. Okay, let's try another example. So we talked already, constants are like terms. So 7 and 10 are like terms. I can combine them, I can add them, I can subtract them. That's what we're talking about when we're talking about combining like terms. Okay, well, let's then look at another example of unlike terms. So if I gave you 2xy and 2xw, those would be considered unlike terms. Now, why would those be considered unlike terms? Well, they have the 2 that's the same. That doesn't actually matter at all. They have the x that's the same. That's great, but they have one has a y and one has a w. So because this part is not the same, then they are no longer like terms. So again, different variables. Okay, on the flip side, if I gave you 3xyz and 5xyz, those are considered like terms. And this has an xyz, and this has an xyz. Okay, let's look at one more example of unlike terms, and then we'll move on. So if I gave you 8y and 5y squared, those are not like terms. Those cannot be combined. Now, why? Okay, they both have a y. They both have the same variable, but their exponent is different. This has a 2. This doesn't have an exponent. Remember, whenever it doesn't have an exponent, we can assume that the exponent is 1. So with this one, it's different exponents. So remember, they have to have the same variable and the same exponent. Sorry, that was a terrible spelling of exponent, apparently. not spelling, but it just looks terrible. Okay, so combining like terms is really important. It's something that we do all year. And so it's something really important to note when combining like terms. Only add or subtract the coefficients. So the coefficients, remember, are the numbers in front of the variables. So when combining like terms, only add or subtract the coefficients. The variables stay the same. So an example of that is if I said 8x squared plus 10x squared, we can look and see, okay, these are like terms, x squared, same variable, same exponent, and I just add the coefficients. So 8 plus 10 is 18. So 8x squared plus 10x squared is 18x squared. So that's all that combining like terms is. You're looking for the terms that are the same. You just add the coefficients, and that's it. Now, the last thing we need to talk about is what we call the distributive property, something you might be familiar with. So the okay, I'm having a hard time with my handwriting today. Okay, so the distributive property what that says, so it is used to simplify the product, there's that word again, of a number and a sum or difference. Okay, so what does that all mean? So first, product. Remember, I already said this, but product, remember that all that means is multiplication. It's just a mathematical way of saying we're multiplying two things together. So what the distributive property says is, let's say I have this example. So if I have A times B plus C, the distributive property says I take that A and I'm going to distribute it to everything that's on the inside of those parentheses. So it's used to simplify the product of a number and a sum or difference. So notice how we have a sum or difference in here. So we distribute the A to the B, and then we distribute the A to the C. So what's going to happen is that's going to be AB plus AC. And we'll deal with this. I know sometimes it's hard to see it as like letters instead of numbers, and we'll of course deal with it in the next example as some numbers. You can see that. Okay, so let's do some examples. I'm gonna flip my page over, so start fresh, and we'll get into that. Now, here's what I will say. There's a lot of different ways that you guys can do this. Some of you guys can see it just without really needing to do anything, which is great. You do that, and I'll show you guys different ways that you guys can kind of combine like terms visually so you guys can visually see it to help you. Okay, so for all of these, we are just going to simplify each expression. And whenever you see simplify the expression or simplify, all that's meaning is like make it its simplest, which I feel like I shouldn't use that word in the description of it, but like smallest form. So if there's anything you can combine it. If there's numbers you can combine together, combine those together. That's all that simplifying means. Okay, so if I gave you the example, y squared plus 8y plus 3y squared minus 8x squared minus 4y squared plus 10x minus 2x squared minus 5x. Okay, we're making it a long problem just to make sure we get it. Okay, so what I do is I start by just looking at my first term, and I look at y squared. So with y squared, I'm looking to see, and for this example, I'm going to show you guys how I do it with like different colored pens. So I look at the y squared, and I look to see where else do I see a y squared. Well, this doesn't have a squared, so we can't use that. This one does. It has 3y squared. So we're good. I keep going. This is x, so it's not the same. Here's another y squared, and that's it. So what I will do sometimes, and you guys can do this, I think it helps to kind of organize, I will write them in one line so I can add them. Now remember, if you don't see a coefficient, the coefficient is always 1. So like this one, there wasn't a coefficient in front of the y squared, so we can assume it's 1y squared. So what I'm going to do is put 1y squared plus 3y squared minus 4y squared. So when I add those, remember, just like I said before, when we're combining like terms, we keep the variable and the exponent the same. All we do is add the coefficients in front. So 1 plus 3 is 4. 4 minus 4, well, that actually gets me 0. That would be 0y squared. And we'll talk about that and how to write that in our final answer in a second. Okay, so then let's move on to 8y. So we have 8y. I'm looking for anything else that has a y. No, 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 that's the only one. So I'm just going to write it by itself in that column. Positive 8y. Okay, then I'm going to move on to my next one. We have negative 8x squared. Looking for anything else with an x squared. Here we go, negative 2x squared. And just like I did here, I'm just adding them. So negative 8 plus negative 2 are negative 8 minus 2. Those are both negative, so my answer is going to be negative. And really what you're doing is just adding them. 8 plus 2 is 10. Throw in the negatives, it's negative 10x squared. Notice we're just adding or subtracting the coefficients together. The variable is not changing. Okay, and then the last one, we have 10x can combine with negative 5x. So I look at those coefficients, 10 minus 5, keep the x the same. That gets me positive 5x. So then we just need to write it, our final answer. Now, typically in standard form, and this will help you guys in your formatives, but in standard form, the way that you'd want to write it is from highest exponent to lowest exponent. So looking at my exponents. Now this one, we'd think about this one, but because the coefficient is 0, 0 times y squared, 0 times anything is 0. So really, this is equal to 0. So we do not write this in the final expression. So if the coefficient in the end result is 0, do not write in the final expression. Okay, so we're excluding this one because of the 0 in front, and so now I'm just looking at those. So I'm looking at first what has the biggest exponent between y, x squared, and x, and it's this one. So I'm going to write that one first. I'm just going to write my answer over here. So negative 10x squared, notice how the sign comes with it. And then with these, it doesn't really matter. I usually do it alphabetized. So in the alphabet, x comes before y. So I would do plus 5x plus 8y. Now notice I kept the signs. If it's positive, it's plus. If it's negative, it would be a minus. So that is my final answer. And when you guys are putting these into formative in your classwork, it helps to just make sure you also write it in standard form too, so you know then it will be also correct. So that's one way of organizing it, is kind of using those colors. You can use highlighters to kind of help you, and then just also keeping it like vertical or horizontal, vertical, keeping it vertical to keep like just looking at the coefficients. That kind of helps that organization. But again, if you don't need some of these steps, then you don't have to apply them. It's just kind of extra steps to help you guys stay organized and keep organized in some of those more challenging problems. Okay, let's try this one. So we have 5x squared minus 10x plus 14y minus 6x squared minus 3y plus 7x squared plus 5x. So what I would like you guys to do is pause this video, try this one on your own, and then come back and see if you got to the same answer. So pause, try it, see how you guys do, and come back. And if not, I'm going to show you guys a different method of how you can like kind of organize yourself in this too. Okay. So another way that you guys can do this, so I did this with colors, and I'm still going to use colors just to kind of help on the notes. But another way you guys can organize this is using different shapes. So with 5x squared, I'm going to circle all my terms with an x squared. So 5x squared, what else has an x squared? Well, the 6x squared. Make sure when you're circling it, you're involving the negative. So that's super important. You always bring that sign in. And then also 7x squared. So I'm again going to write those just down one line. So 5x squared minus 6x squared plus 7x squared. And I can start there. Okay, so 5 minus 6 is -1, and -1 plus 7 is actually 6. So we have 6x squared. Notice the variable and the exponent don't change. So then when I go to the next one, I would use a different shape. So -10x, I'm looking for anything with an x. So no, yep. And so I'm going to use a box for those. So -10x plus 5x. So -10 plus 5 gets me -5x. And then my last one is the y's. I'm going to use a heart for those. So 14y can combine with this -3y. And then I can combine those. So 14 minus 3 is 11y. And it's positive. Okay, so now I'm going to write my final answer. Remember, I want you guys to start with the biggest exponent first. So x squared is my biggest exponent. So 6x squared, and then go alphabetically, x and then y. So minus 5x plus 11y. And that is my final answer. Okay, we have 2 more examples, and then we will be done for the day. So let's actually bring in the distributive property. So number 3 is going to be 6 plus 2 times the quantity. That just means we're multiplying it by a large group. So it has that parentheses. X squared plus 3x cubed minus 10 plus 3x squared minus 8x cubed. So make sure when you guys are writing these down, you're writing down the correct problem. If you're not writing down the correct problem and then you have the answer for mine, you might get confused if you're looking back at your notes. So the first thing you want to do, we're kind of going back to GEMDAS, right? We're thinking back to order of operations. And the first thing we do, we would look at the grouping symbols. There's nothing I can simplify in here. There's no like terms between x squared, x cubed, and -10. So my next step would be to multiply. Now, a lot of you guys are gonna wanna like add these first, 6 plus 2, but that would be incorrect. So the first thing you wanna do is take this 2 and you wanna distribute it to everything inside the parentheses, the x squared, the 3x cubed, and the -10. So really, really important, we multiply or distribute before we add. Before you add. So what happens when we do that, the 6 just comes down. It's not even touched yet. So then 2 times x squared, remember that's just 1, so it's 2 times 1. That becomes 2x squared. And then 2 times 3x cubed. Well, we're multiplying the 2 with the 3. So that's 6x cubed. And then 2 times negative 10 is negative 20. And then everything else just comes down. And now I have a problem like I did in 1 and 2. So if you guys are feeling good, feeling confident, then you guys can pause me here, finish number 3 on your own, and then come back and check your work. Or if you're not feeling super confident, then we can still go through this one together. Okay, so I'm going to start by looking at the 6. So what else can combine with the 6? My purple's running out. It has to have no variables, so the negative 20. There we go. So 6 minus 20. Okay, well, we know, okay, 6 minus 20. Now, if you're still struggling with adding and subtracting integers, adding and subtracting numbers, use your calculator. There's no shame in using the calculator. 6 minus 20 gets me negative 14. Great. Okay, then I move on, my 2x squared. I look for anything else with an x squared, 3x squared. And now I can combine those. So I just add the coefficients. 2 plus 3 is 5x squared, and that's a positive 5x squared. Okay, I move to my next one, 6x cubed. So I'm looking for anything with an x cubed, negative 8x cubed. Now the one thing like why I kind of like to like underline is so I'm not looking anymore at these. Like I know I've dealt with those already. So we have 6x cubed minus 8x cubed. 6 minus 8 is negative 2x cubed. Okay, so when we write that, remember we write it from highest exponent to lowest. So my highest exponent is x cubed. So I'm going to start by just writing negative 2x cubed. Then my exponent would be 2, so plus 5x squared. And then your coefficient or your constants always go last. So minus 14. Okay. So again, if you guys are going through this and you guys do have questions, remember to bring those to class. We can go over them together because if you have a question, I'm sure somebody else has a question too. Okay, last problem. So 2 minus the quantity of 3x squared plus 5x minus 2 minus 8x plus 3x squared minus 10. So first thing we want to do, can I simplify anything in the parentheses? And I can't. So the first thing I'm going to do is I'm going to distribute. Now, what am I distributing? Well, remember, you're just distributing this, but there is no number there. What number can we assume is there? We can assume there's a 1. So we're actually distributing this negative 1 to the 3x squared, to the 5x, and to the negative 2. So if you're feeling confident with distributing and then combining like terms, you can pause me here, finish the problem, and come back and check your work. Again, if you want to go through it with me, we'll go through it right now. Okay, so I'm just going to keep this 2, stays the same, but now negative 1 times 3x squared is negative 3x squared. Negative 1 times 5x is negative 5x, and negative 1 times negative 2 is positive 2. And then everything else just comes down. Okay, so from there, I just start by combining my like terms. So I look to see what's the same. 2, I can combine with this 2 and with this 10. So we have a positive 2. We have another positive 2. And we have a negative 10. Like where the paper is, it's not writing well. Okay, so 2 plus 2 is 4. And then 4 minus 10 gets me negative 6. Okay, so then we'll move on. So we have negative 3x squared. Keep looking for other x squareds. positive 3x squared. Well, negative 3 plus 3 is 0. 0x squared, remember, we're not going to actually include that in our final expression. Just like in number 1, when we had that 0y squared, we're not including that in our expression. And then lastly, we have negative 5x minus 8x. So negative 5x minus 8x. So that gets me negative 13x. So now I just have to write my final answer. I go from biggest exponent to smallest. This one has technically the biggest exponent. That exponent is 1, and then negative 6. Because remember, we're not putting this in our final expression because it's 0. So my final answer is negative 13x minus 6. And that is the notes, guys. If you guys have any questions or need any additional practice or problems that you want to go over, please make sure you're asking in class. And that is it for the notes, and that is it for this section. So we are going to be starting to prepare for your test now. So have a great day. Make sure you're reading your notes, and I will see you guys soon. Bye.